Hi everyone. In this video we shall see that how we can create a scalable depreciation schedule using written down value method with the help of dynamic array functions in Excel. This challenge was proposed by Chinmay Amte on Excel. Do check out this and his other insightful posts as well. I will attach the link of this post in the comment section below. And make sure to follow him on LinkedIn for more such awesome challenges and content on Excel and finance. And you may also check out other insightful solutions which are posted here. So do check out this. And I will also attach the link of this workbook in the comment section. This was the challenge, and this is the data on which we will be working on. So let's first of all see that how do we create a depreciation schedule using old school way, right? So we will not be using dynamic arrays here, and then we will later on see that what is the advantage of using dynamic arrays and how we can make this depreciation schedule more scalable. So let's say we have this information here that our starting year is 2023, our opening asset balance is 100 million, then the depreciation rate that we are charging is 12%, and we are creating a schedule for 10 years. And this is an Excel table. So if we see, we have this table design tab here, and the name of this table is TBL dep and table for depreciation, and this indicates the new asset purchase each year that we are making. So we could add anything here, right? Every year the purchase we are making or any disposals we are making, so that is indicated here in this table. So we are going to use this table as well. So let's see that how do we create depreciation schedule using old school way. So our first step would be to create a list of all the years for which we are creating the depreciation schedule. And the first year that we have is mentioned here. So we will refer to that cell here, equals to, we will refer to this cell C5 and let's press enter. And then in the subsequent cells, what we will do, we will reference the previous cell and we will add one to that. So we are incrementing the years by one, and we will drag it across to multiple cells. So now we have 10 years here, the depreciation schedule for 10 years, right? We are creating from 2023 until 2032. Now the next step is to find out the opening balance. So for 2023, our opening balance will be equals to, we are given that amount here, so it is 100 million INR, and let's press enter. So we have the opening balance. Then in order to find out any additions in any of these years, what we will do, we can use sum ifs function here. So what we will do, we will use sum ifs function, and our sum range will be this addition column in this table, comma, our criteria range will be the year column in this table, and our criteria will be this year here, right? So let's press enter, and we have zero additions in 2023. Let's say if we add another row here for 2023, and let's say we added assets worth 90 million in this year, so 90 is generated here, right? But right now we could remove this. So we have zero additions in this year. And then in order to find the depreciation, what we could do, we could simply, first of all, add the opening balance and the additions we did in that year. So we have got this here, and then on this balance, we will find the depreciation by multiplying this addition with the depreciation rate here. Let's press enter, and we have got depreciation here, which is 12 million. Now our closing balance will be, again, this depreciation will be in negative because this is an expense. So we will show that as a negative number. Then our closing balance will be the sum of all these three components here. That is opening balance plus any additions during the year and plus the depreciation. Again, that is already in negative, so we could directly add that here. So we have got the closing balance here, which is 88 for year 2023. Now when we move on to the next year, that is 2024, our opening balance will be the closing balance of the previous year. So we will select this cell, refer to this cell, press enter, and the opening balance for 2024 will be 88 million. Now additions for 2024 here again will be the same formula we can use, that is sum ifs, and our sum range will be this additions column, comma, our criteria range will be the year column, and the criteria will be 2024. Let's press enter, and we have got this as our result here. So no additions in year 2024 as well. Now, in order to calculate the depreciation, again, what we can do, we will add the opening balance and the additions that we have done during the year and multiply that with the depreciation rate. Let's press enter and we have got the depreciation here. And again, we will use a negative sign here. So we have got that here. Now, closing balance, again, that will be opening plus any additions plus the depreciation. So we have the closing balance here as well. Now, in order to do that for each of the subsequent years, what we can do, let's say we select this range here, press F2 key, and let's press Control Enter. So we have the opening balance for each of these years here. Then again for additions as well, we could select this range here, press F2, and let's press Control Enter. So we have got additions as well for these years. So addition in year 2026 is 20 million INR. So we have that figure here. And again, in year 2028, we disposed assets worth 30 million. So we have got that here as well. Now again, same thing for depreciation as well. So let's press F2, Control Enter, and we have got our result here. This thing will get sorted once we have the closing balances here. So let's select this F2, Control Enter, and we have got the result here. So let's check out that what is the issue that we are having. Okay, so we have forgotten to fix this depreciation rate here, right? So for doing that, what we will do, we will go here and we will fix this, right, by pressing F4 key. So we will fix this reference because again this will be fixed to this cell C7. So let's press enter and let's update our formula here, F2 and Control Enter. So we have got our depreciation schedule for all the 10 years here, right? Now let's say we have depreciation here 12 million, 10 million, and it is reducing, right? Each year it is reducing. Now, what is the problem with this old school way? This is easy to do. In no time, we created this schedule. And again, this is very convenient for us to build. But the problem is, the one problem that we again indicated here is that we have to fix these cell references as well and take care of all these issues as well. But let's say this is not a very big problem. The main problem is that this is not scalable. Let's say if we change the years to, let's say, 5 years, then as well this is not updating, right? We could argue that okay, we could create some formulas in order to automate that thing as well, but again there would be some limitation and we will have to drag this formula across many other cells, right? So this is not much scalable. There will always be some level of limitation that we have, right? So because of that, the old school way is not much scalable, and hence we will see a way out using dynamic array functions and how we can utilize the power of using tables along with dynamic arrays to create a scalable depreciation schedule. And the same concept can be applied to many other areas as well. To make things scalable and dynamic, make use of tables and dynamic array functions. So let's see that how we can automate each component here that we have done manually using old school way. And again, one more problem to this is that let's say here we are using a different formula and in all the other cells we are using a different formula. So again, in order to make things consistent and scalable, we will see a way out using dynamic arrays. So let's see how we can generate each of the components here using dynamic array functions. So let's start with the year. So let's see how we can create this list of years dynamically using dynamic array functions. So for that, what we will do, we will use sequence function. So equals to sequence, and we don't have to generate any rows, we have to generate multiple columns. So we will skip this parameter. How many columns? Again, that is indicated here. That is, let's say 5 columns, because we are creating a schedule for 5 years. So we will select this cell here, comma, what is the starting year that we have? It is year 2023. So we will select this. Let's close the bracket, let's press enter, and we have generated this list of 5 years. And again, this is dynamic. Let's say if we change the years to 10, this is scalable, right? This is automatically expanded to 10 columns. This is the advantage of using dynamic arrays. And we will see that how these things are also automated. Now we will come on to opening balance later, and let's try to automate additions for now. So what is the formula we have used here? We have used sumifs here, right? So we will use the same sumifs function here, but we will make it scalable by using dynamic arrays. So equals to sum ifs, and our sum range is again this additions column, comma criteria range is this year column, and our criteria will not be a single cell but the entire array. And again, this pound sign indicates that this was a dynamic array. So if the size of this dynamic array changes for the years, then this will automatically change, right? So what we will do, we will close the bracket here and let's press enter. And this is a dynamic array, right? We have generated this here. Let's say if we change this to 6 years, so this dynamic array are generated automatically, they shrunk automatically. If we expand that, let's say we make it to 12 years, so they are expanded automatically as well. So that is the advantage of using dynamic arrays. So let me switch it back to 10 years. So we have got this result, right? So we have the additions here. Now we will see that how we can mathematically calculate the depreciation here, closing balance here, and then the opening balance here, right? So for that, let's move on to the working sheet and do some calculations here, do some working here. So first of all, let's just observe one thing, that how are we arriving at, let's say, closing balance here, right? Closing balance and the depreciation here. So we will try to automate these things by making the use of equations here. So let's move on to the working sheet. So let me use the pen and let us select this pen, right? So what is the equation that we have for depreciation? How, let's say we indicate the depreciation by dn, right? Then let's say opening balance by on, for let's say n here it is indicates the year 2026, right? So dn for depreciation, on for opening balance in year 2026, in any given year. N could be anything, but for now we are assuming 2026. Then let's say we indicate closing balance by cn and the rate of depreciation by r. We are not using any n here because r will be constant. We are assuming that r will be constant across all the years, right? So we are using dn, on, cn and r here. Now as per the equation, what we are doing, that how do we calculate, how are we calculating depreciation here? So dn is equal to on plus, okay, one more thing, an, right? An for additions here, any additions that we did during the year. So on plus an into r. This is the same equation that we are using Excel as well. So if we see here, what is the equation that we are using here? So let me switch back. How are we calculating depreciation? By using this equation, that opening plus any additions into this rate here. So we could see that in the formula as well, right? So let's switch back to the workings here. So we have this as our equation 1. So we could write here. Okay, let me switch back to the pen here. So this is equation 1 for us. Now, how are we calculating the closing balance? So let's see that as well. So for that, Cn is equal to, how are we doing that? Again, let's assume that Dn is a positive number here. So what are we doing? We are adding On plus any additions, opening balance plus any additions minus depreciation. So minus dn here. Right, right. This is how we are calculating closing balance. Now we can use equation 1 here. So in order to further break down Cn, closing balance here. So for that we can write Cn equals to On plus An minus On plus An into R. Again, this is coming from equation 1, right? So we have this here and we can further break this down. So Cn is equal to On plus An minus On into R minus An into R, right? We can further break this down. So Cn is equal to On. So we could take On common. So On common and 1 minus R plus we can take An common, right? And then in the brackets 1 minus R, right? So we are taking this part and this part, and then we are taking On common. Then we are taking this part and this part, and we are taking An common. Then we can further break this down. So if we write here Cn is equal to, we now we can take 1 minus R common, right? We can take 1 minus R out, and what we have inside, we have again On plus An here, right? So let me move down here. So we have this here. Now this is equation 2 for us. Okay, this is equation 2 for us. If we compare 1 and 2, equation 1 and 2, what do we see? What is the common component that we have in both the equations? It is On plus An, right? It is On plus An. So if we, let's say, break down equation 1, so from equation 1, if we see On plus An is equal to Dn by R, right? We have this. Now if we combine both these equations, let's say this is equation 3 for us. If we combine equation 2 and 3, what do we get? Cn equals to 1 minus R into dn upon R. Or if we reverse the equation, what we can say that dn is equal to Cn into R upon 1 minus R, right? So overall, what we can say, that how do we find out depreciation? If we have the closing balance for each of the years, then depreciation is simply closing balance multiplied by rate upon 1 minus depreciation rate. So this is the equation that we are going to use, right? This is the equation that we are going to use, and we have arrived at it mathematically. Now, in order to find out closing balance as well, what we can do, we can again further break down closing balance here. So if we, let's say, see closing balance here from equation 2, so what do we have from equation 2? What do we have? Cn is equal to, again if we see the second equation, Cn is equal to 1 minus R into On plus An, right? If we closely observe, what is the On? Let's say we were assuming that N is 2026. So let's see that what do we have for 2026, right? So if we switch back to Excel mode, if we see here, this is the closing balance for year 2026, right? Which is again opening balance plus additions minus depreciation. How we have again created an equation for depreciation. Now, if we see what is the opening balance here, opening balance is for 2026 is the closing balance of year 2025. So, can we say that opening balance of nth year is the closing balance of n minus 1th year, right? If we see opening balance for 2026 is the closing balance of year 2025. So, that same thing we can do here as well. So, we can say that closing balance of nth year is equal to 1 minus R into closing balance of the previous year plus An, right? So we can say that, yes, we can say that, right? So we have this equation here. This is another equation that would be of help for us. So we have this here. So we are going to use these two equations, and we will see that how we can use these two equations in order to arrive the final result and create a scalable depreciation schedule. So let's say first of all we will utilize this equation here in order to find the closing balance for each of the years, and then later on we could utilize this equation in order to find depreciation using that closing balance, right? And then finally we will also add them up together in order to find opening balance. So that's how we will approach this problem here. So we have this here. Now let's see that how we can carry this thing out using Excel functions. And again, for this equation, for our first target will be solving this equation, solving out this equation using Excel functions. And for this equation, one of the best use cases we can find for this equation is in scan function. So scan function is almost perfect for such kind of condition. We will see that how we can use a scan function for solving this equation. So let's switch back to Excel mode and let me keep the board aside. Right. So let's move to Excel now. So here in this equation, what we are saying at Cn minus 1, right, the previous result that we will arrive plus any additions multiplied by 1 minus r. So let's see that how we can do that. So let's say we start with year 2023 here. So for year 2023, what is the previous closing balance that we have? The previous closing balance that we have here is this 100 million, right? This is the closing balance of the previous year. So we will write that here, let's say. So we will write the closing balance of the previous year. So we will reference this here. So again, in order to implement this equation, what is this equation? So let's see that here. So equals to 1 minus r. So we will have to refer to this cell, and let's fix this cell as well. Multiplied by what? The closing balance of the previous year. So we have that here plus any additions that we did during the year. So we will add this here, right? This the additions here. Let's close the bracket here, press enter, and we have got this result here. And again, this is exactly same as this closing balance here. Let's drag it across. And what formula do we have here? Again, we have fixed this rate here and additions and any and the closing balance of the previous year. So we already have that here, and we have this thing here. So we have this formula here. Let's drag it across. And if we see, we have got the closing balances and the figures are exactly same as what we did here, right? So we calculated closing balances here using the simple additions here. Right now, what we are doing, we are using this equation in order to find out the closing balance. So which function can we use in order to automate this calculation, which also allows us to refer to the previously calculated result here? So what we are doing basically that at each iteration, we are utilizing the previous result and this current additions in the current year. Again, what we are doing, we are utilizing the previous result that we have generated and the additions that we have done in the current year. At each step we are doing this thing, and what we can say that we are again looping through each of the additions that we have done in each of these years here. We are arriving at a result, and that result we are using in the next step. So which function can we use here? The ideal function to use here is scan function, right? Because scan function is made for such kind of situations in which we are referring to the previous result and any array through which we are iterating one by one, right? So what we can do, we can use a scan function here. So equals to scan. What is our initial value? What is the closing balance that we already have, right? Closing balance of the previous year that we have here. It is this number here, which is 100 million. And we don't have to fix this here, right? This is the advantage of using dynamic array functions. This is the initial value that we have. What is the array? What is the array through which we are iterating one by one? So this is the array that we have, because at each step we are using the values from this array, right? So this will be the current value that we have in each of the year. So this will be our array, comma, we will write our functions. So for that we will use lambda. So lambda, and let's denote the previous result, the closing balance of the previous year, by x, and each of the additions that we are doing in the current year by y, right? So x is the previously calculated closing balance and y is the additions in the current year. Then how do we calculate the closing balance for the current year? Again, for that we will use that equation. So 1 minus this rate, and we don't have to fix this here, 1 minus rate multiplied by X, which is the closing balance of the previous year, plus any additions that we have done during the year. So y, x plus y, just this formula here, press enter, and we have generated the closing balances for each of the years using scan function. This is dynamic, this is scalable. So if we, let's say, change our years to 5, so this is again reduced to 5 years, but this is not, right? We will have to carry out certain conditions here in order to shrink this to 5 years only, right? So this is not scalable, but this is highly scalable. And if we, let's say, change this to 30 as well, 30 years, so again you can see that this is right now it's expanded until 30 years. So that's the advantage of using dynamic arrays. And again, we don't have to care about any fixing anything here, right? We have just used the direct references here. Okay, so let me keep this here just for reference, and let me copy this formula and apply this here. So we have the closing balances here automated for us. So let me change this to 10 back, and we have this here. Again, the results are exactly same here, right? If we check that as well, so equals to this equals to this. So we have true here. And if we check for all the subsequent years as well, so this is true for all these years, right? We could remove that from here. So we have the closing balances here. Now we have this here. Now how is depreciation calculated? It is simply closing balance multiplied by rate divided by 1 minus rate. Right? So depreciation is very simple, equals to, again, closing balance multiplied by rate divided by 1 minus rate. So in the brackets 1 minus rate. We don't have to fix anything here. We don't have to care about that. So we have this for 1 year. If we have to calculate that for every year, for every closing balance, so what we will do, we will just insert a pound sign here in order to refer to that dynamic array. Let's press enter, and we have the depreciation here as well. Again, this is all automated. This is all scalable, and we could insert a negative sign here in order to show depreciation as a negative number. Right, so we have depreciation here, we have closing balances here. How can we calculate the opening balance? Opening balance will be simply closing balance plus the depreciation here, right? So we can add these two dynamic arrays. So we have the opening balance as well. Okay, so we have to basically subtract this because depreciation is a negative number here. We are showing that as a negative number here. So minus depreciation. So we have the opening balance as well here, right? And again, if we check with the old school way, because we know that old school calculations are correct here, so we are just checking that are we generating the correct result or not. So if we check the condition here, let's say for opening balance is equal to the opening balance we generated using dynamic arrays, so we are getting true here. And if we drag this across, again, this is okay, what is the issue that we have here? Okay, I got it. So we will, in this opening balance, what we will have to do, we will have to subtract the additions here, right? Because these additions are not a part of this. So again, that's how we could use such kind of checks in order to validate the results as well. So from the opening balance, we have to subtract any additions as well, right? We have to subtract the depreciation, we have to subtract the additions, and we have to add the closing balance here, and hence we are getting the correct opening balances here as well, right? So we have checked the opening balance, we have checked the closing balance already. Now let's check the main part, that is depreciation here. So is depreciation equal here? So let's see that. Let's press F2 key and let's press enter. So we have those checks here. So those figures are true, and hence we have created a scalable depreciation schedule using tables plus dynamic arrays. So let's say if we add any new here uh, to this purchase table here. So let's say we purchased an asset in year 2024, and let's say we purchased worth 50 million of assets in year 2024. So we have that here. Again, this is all scalable, and let's say we scale it to 100 years. So this is very scalable. This is highly scalable, and we have the depreciation schedule for next 100 years. And we could add any assets here. Let's say we add 500 here. So we have all the figures changing here, and we have this depreciation schedule ready for next 100 years. If we change the rate here, let's say we change the rate here to 20%, right? So we have all those things generated here. Let's say we change the opening balance to, let's say, um, 200 million. So that is also updated here, right? Let's say we change the starting year as 2024. So we have that here, right? This is all scalable. Let's change that back to, let's say, 13 years. So we have the depreciation schedule for 13 years. So we just have to change these inputs here, and everything is scalable. Everything is automatically generated here using dynamic arrays. And we have also seen that we can break down the complex problems into simpler ones by using mathematical equations, and how we can combine the mathematical equations with Excel functions in order to create such scalable models. So we can, and again, we can apply the same concept to build more complex models and same in some other models as well. So that's it for this video, and I hope you would like this concept, this idea of using dynamic arrays and combining the dynamic arrays with mathematics, with equations, in order to arrive at such solutions. So that's it for this video. I will attach the link of this file in the comment section. Do check out that, and feel free to drop any suggestions, any feedback in the comment section. So that's it for this video, and make sure that you check out this challenge and you follow Chinmay Amte on LinkedIn. So thank you, and hope to see you in more such videos in future.